Hi, my name is James the Geologist, and today we're going to talk about density, seawater density. Ah! James the Geologist here. So today I'm in the middle of Eagle Mountain Lake and getting a little bit of my exercise in. As you can see behind me, I am on a kayak. So what I wanted to do is talk to you about the lab that we're going to be going over. So it's going to begin our understanding of the spatial variations of the temperature and the salinity in the world's ocean, and basically how these factors might affect the circulation processes, such as your water mass mixing and your upwelling, right? So when we think about density, we need to think of it in terms of temperature, salinity, and pressure. So these three things are really going to control the density of the seawater. So we're going to focus on the effects of temperature and salinity only because the pressure effects that we see are just going to be a small fraction in the upper 1,000 meters of the water column. So seawater, as we know, right, so the oceans, they are 72% of the surface of the Earth. The seawater is going to absorb solar radiation. Usually the heat causes the water to expand, thus lowering its density, right? So we can think of this as in the atmosphere when hot air, right, we think of it rising, and the cold air, it subsides and it sinks. So when we think about the warm and hot, right, so what's causing that hot air to rise is that it's actually becoming less dense. So the seawater absorbs solar radiation, and we can think of thus lowering the density, right? So we're going to think of density with a little, I guess that would be P or a P. So that's going to equal mass over volume. So this is the units that we're going to use when we think about density. So conversely, when water cools, its density is going to increase. So the permanent thermocline is a water layer within which temperature decreases rapidly with water depth. So what this is meaning is that as the temperature decreases, it's going to increase its density, and therefore it's going to have a tendency to sink as well. The thermocline, we're thinking thermo, is going to deal with temperatures, and this is going to affect the densities of water as well. So those are the two that we're going to be focused on, is going to be the salinity and the temperature. Two things, boom, easy to remember. When we think of salinity, we can also think it's going to be the measure of any substance that's going to be dissolved into the seawater itself. So this can include what? So we think there's a chapter that's called air-sea interactions, right? So the atmosphere is actually going to play a role in the mixing of the water. So we can assume, one, that there's going to be gases that are going to be mixed into the water. And this is going to include oxygen, O2. It can be in the form of carbon dioxide. We see that the carbon dioxide easily dissolves in the water. Two, nutrients, right? The main nutrients that we're going to see is going to be in the form of nitrates and phosphates, so NO3 and PO4, and then also trace elements. So we can also think of, in terms of dissolved substances, is going to be dissolved organic molecules, and then lastly, we're going to think of it in terms of minerals and salts. And the average salinity in the oceans is going to be about 34.73 per mil. And when I say per mil, it's going to, if you think of the percent sign, that's woo, and the 10 per mil, it's going to be the 0/00, because this is going to be basically per thousand. Well, it's not basically, it is. It's a per thousand unit. When we think of it in terms of ocean water, we can think of grams per 100 or per 1,000 grams of seawater. We can determine the percent of salinity of seawater by the weight of the salt grams compared to that of the seawater grams. We know salinity, so if we do the grams of salt per grams of water, right, so then we can get a measurement. We can just take water. If you remember from your conversions, 1 mil of milliliter of water is the same as 1 gram of water. Then you just multiply this number by 1,000 to get the PPT in situ density. So I measured out 10 grams or 10 milliliters of water, right, in this 16 milliliter thing. So with me, I have about 5 grams of salt. So if we know this is 10 grams or 10 milliliters, 10 grams, same thing, of water, right, and we were to put roughly, let's say, well, we can do, all right, so let's say we were to put 1 gram of salt in there and mix it up, right? So we would know the salinity of this water, right? So you could say that it is, right? If it's 10 grams, you do the 1 divided by 10, right? So then that would give you 0.1. You times it, so it would have 10% salinity, or 100 per mil. All right, so if you put the whole thing, so you can think which would have more density when I first put all the salt in, when I put a little bit of the salt in versus all the salt. So we're actually affected. Oh my goodness, I'm just drifting. So here I'm putting all of the salt here. So if that's 5 grams by weight, and we have 10 mils of water, so that's 10 grams of water. Right, so we could say that, or if it's 5 grams of salt versus 10 milliliters of water, we can say that it's 50% salinity, or 500 per mil. Right, and that's nowhere near what the oceans is, right? So if you thought of percent, it's about 3.4% versus your 34-ish per mil. So that's basically how we calculate salinity. Right, so what would happen if I were to heat this up? Would it increase in density or decrease? Versus if I were to cool this down, would it increase or decrease its salinity, or not salinity, density? I'm all over the place. I'm distracted. I have these in my face. It's a big mustache. I must ask you a question. How do y'all feel about density and salinity? Ah, there's a big spider! Oh no! Oh, I'm stuck in a boat with a big spider. Ah! Oh my goodness. Ah! No, I don't know where it went. I don't know where it went. Ah! Ah! Oh my goodness. Oh my goodness gracious. What am I gonna do? Oh, I don't like spiders. Ah! Ah! There it is. Ah! Ah! Wasn't lying, there's a big spider on my hand. So in today's lab, we're also going to do an experiment in the lab that's going to correspond with kind of this talky talk. All right, so I talked about the densities, so let's take it to the lab and see what's going on. Safety first.
All right, for today's experiment, we're going to use a hydrometer. So our first step that we're going to do...
Oh, shoot.
All right, so for today's experiment, we're going to work with a hydrometer. So first, some of the equipment that we're going to use is a graduated cylinder, some salt. We're going to measure the temperature with a thermometer, and of course the hydrometer. The hydrometer, notice that has a weighted end. It's filled with lead. It also has a measurement. This is where we're going to get our density measurement. So the first thing that we want to do to complete this exercise is to fill the graduated cylinder with water up to the 400 milliliter line.
$400 milliliters of water.
Alright, so after we filled the cylinder with 400 milliliters of water, we want to add about 14 grams of salt to the water. And then we're going to add the salt to the water until it's dissolved. It's important to try to be as accurate as possible, so we're going to use an electronic scale.
I hope you've enjoyed this little kayaking tour. Hopefully it wasn't too distracting with my arms just bow, bow, bow. Until next time, this has been James the Geologist, and I wish you the best. I can hear my dog barking from across the lake. And that's no joke. Uh-oh. Did it stop recording? Woo! There are my notes. And it's awfully bright out here. We can, don't even blah, 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 take that out. Ooh, let's see what's happening. Halt that down real quick. Oh, no, we're still recording. Ooh. Say your words today, right, James?